Hello again. We're going to look today, or in this video, we're going to look at mathematical proof. And we'll start with the most basic sort. What can we say about three consecutive integers? At the most basic level, we can say that they are odd, even, or odd. That would be if our first integer was odd, and the second one would be even, and the third odd. Or, of course, I could have started with an even integer. Then the next one, the second one would be odd, and the third one would be even. What can we say about the product of those? That is when we multiply them. Well, if one of our numbers is even, when we multiply, the answer must be even. So the product for the first one would be even, and it would be even for the second. What about the sum of those numbers? Can we say anything about that? Well, if you add an odd number to an even number, you get an odd number. What about two odd numbers? What would that be? Well, these two must add up to an even number. Two odd numbers are even. Added to an even number, that must be even. An even number plus an even number is even. So the sum, if we began with an odd number, must be even. Let's just check that's true. 1, 2, and 3. Add those together, and we get 6. But what about if we began with an even number? An even number added to an even number is even, and then add an odd number, it's going to be odd. Let's just check that with an example. 2, 3, and 4. Add those up, you get 9, which is an odd number. So we can't say anything for sure about the sum of three consecutive integers, but we can say something, as you saw earlier, about the product. Now, that's at the most basic level. The second bit about mathematical proof is this whole bit about giving a counterexample. Here we go. Somebody makes this assertion that the product of 10 and any number is a multiple of 10. Put more simply, it ends in 0. Now let's think of some examples that prove that. Yeah, 10 times 3 is 30. 10 times 91 is 910. But the counterexample hinges on us spotting that they said any number, not any integer. What about 10 times 2.1? Well, that's 21, and 21's not a multiple of 10, doesn't end in 0. So, to disprove an assertion, we just need one counterexample. Now, the third bit of mathematical proof is more just about algebra. Here we go. You might just see this simple word, or single word, prove. Here we go, and it is 2n plus 1 all squared is always the same as 3 n squared plus 1 plus 4n plus n squared take away 2. Well, how do we go about this? Well, it's all about proving that the left-hand side is equal to the right-hand side. So we expand this bracket here on the left, and you get 4n squared, that's this term squared, plus 1, and then remember you get twice the product of the two terms, so it's plus 4n. So that's the left-hand side. Is that the same as multiplying out this bracket, 3n squared plus 3 plus 4n plus n squared minus 2. Let's check. Gather together like terms, we get 4n squared. Gather together the n terms, well, there's only one, isn't there? So it's plus 4n. And then look at the constant terms, the numbers, we get plus 3, take away 2, which simplifies as plus 1. So yes, we've proven the left-hand side is always equal to the right-hand side. Now, the last type of proof is the hardest. Okay, here we go. Show that the sum of 3, and here's the key word, consecutive odd numbers is always a multiple of 3. Now, it says show, or it might use the word prove. This won't do. Let's say I chose at random 5, then the next consecutive odd number is 7, and the next one after that is 9. If I add those up, 12, I get 21, which is 3 times 7. It's a multiple of 3. But that doesn't show or prove. I've just demonstrated that in one instance, when I start with 5, it works. And I could pick another number, odd number, 11. The next one after consecutive odd number is 13, then 15. I could add them up and I get 39, which is 3 times 13. Yeah, it happens to be a multiple of 3. But that could just be coincidence. I've got to try and prove it algebraically. And the way to do it is this. First, we define, let n be any integer. Then, in terms of n, I have my starting odd number. 2 times n must be an even number. If I take away 1, it must be odd. What's the next odd number after that? Consecutive one, it's 2n plus 1. Because remember, the odd numbers, like the even numbers, go up in 2, and then the third one would be 2n plus 3. I now add these all together to give me 6n. That's gathering together all the n's. And then gather together the constant terms, minus 1, add 3, gives me plus 3. I'm almost there. And if I factorize it, I get 2n plus 1. And as we can see here, 3 times any integer, which 2n plus 1 must be, is always a multiple of 3. There we go. Okay, thank you. I hope that helped.